Okay. So yesterday we have seen what are the different types of cooling loads that need to be encountered. Today we will be starting with the uh, numericals to calculate or estimate the cooling load and what are the different factors that you need to find so as to account for all the loads that are entering a particular room or a hall or a restaurant. It can be anything. So these are important terms that you need to keep in mind and remember as well. First one is the sensible heat factor. I believe everyone knows what sensible heat factor is. We have discussed this yesterday as well. It's nothing but the ratio of sensible heat to the total heat. So total heat is nothing but the sum of sensible heat and latent heat. Next is the room sensible heat factor. Okay, this is exactly the same as sensible heat factor, but only thing is that it is applied to the room. That means that we have to note down or estimate all the heats that are there for a particular room which is supposed to be cooled. Okay, for example, if it is your bedroom, then you will have to consider the solar radiation that's coming inside, the conduction through the walls, the heat emitted by the equipment, devices, etc. Okay, so this room sensible heat factor is related to the room which is supposed to be cooled. Okay, so it holds the same formula, that is the room sensible heat upon room sensible heat plus room latent heat. Next is the grand sensible heat factor. Okay, this is the ratio of the total total heat load that the conditioning plant must handle, which also includes the outdoor heat loads. For example, the this basically takes into consideration the outside heat load also that enters. Okay, now in your normal residential applications, there is no as such a requirement of dedicated recirculation of air. Okay, now when I say recirculation of air, that is the only purpose is to ensure that the oxygen levels are maintained in the safe zone as recommended by ASHRAE. So for larger applications such as your hotel rooms or your office spaces which has got multiple cabins, meeting rooms, etc. In such situations, the occupancy is for a large amount of time. So there also, to maintain the work efficiency, there should be some kind of recirculation so that fresh air can enter. So grand sensible heat factor includes the total heat load that your conditioning plant or your evaporator coil must handle, which also includes the outside heat loads, which also includes your infiltration and your recirculation air. Okay, okay, is grand sensible heat factor clear to everyone?
Yes.
Yes, sir.
Okay. So one thing you need to also infer from this is that the slope of grand sensible heat factor line. Okay, now we know what the sensible heat factor line is, right? The process of cooling and dehumidification for your summer air conditioning. If we take an example, it is going to be a line with a particular slope depending on the amount of latent heat. Okay, depending amount of depending on the amount of this latent heat that is there. Okay, so if this latent heat is larger, then your denominator value will be more and your sensible heat factor will go down. Okay, so you can just infer from these two definitions that the slope of GSHF line. Okay, this line is similar to your sensibility factor line or RSHF line, which is going to give you an idea about the nature of load inside. So from these two definitions, we can easily come to a conclusion that the slope of your GSHF line is going to be more as compared to the RSHF line. Okay, is anyone having doubt on this?
No, sir.
Okay, because of the
No.
obvious fact that your GSHF is the or your grand sensibility factor includes the outside loads as well, so it has to cater to greater amount of uh, latent heat and sensible heat. So this line will be more steeper. For instance, if this is your RSHF line, then your GSHF line may be of a greater slope. Okay.
Yes, sir.
Okay. So with this, we can proceed to how to actually plot these lines. Okay. Now, this is your simple RSHF line. Okay. Here, your this is the room condition. This R that is mentioned over here. Just a second. This R that is mentioned over here. Okay, this is your desired room condition. For example, you want your room to be at 24 degrees and 50% relative humidity. Then this point is going to represent that. That becomes your room condition. And the loads inside the room. Okay, the loads inside the room, which you will be evaluating, that is the total sensible load and the total latent load. On the basis of that, you will get the RSHF number. Okay, your RSHF number. Okay, so on the basis of the RSHF number, you will be drawing this line, that is your RSHF line, originating from your room design condition, because from this point you have to uh, cool and dehumidify the air. Okay, because the air that comes inside the room, the cooled
Hello.
air, is naturally going to be cooler than your room design condition. So this line is going to represent that cooling and dehumidification process at which the supply air must be supplied, okay, or the cooled air must be supplied. So over here, S that you can see over here, this S is your supply air condition. Okay, that is the condition of air that leaves the evaporator coil and enters the room. Okay, so this is going to be your uh, cooling and dehumidification process along this line for your room conditions, or your room sensible heat and room latent heat. And over here, ADP, everyone knows what ADP is. Yes,
Yes, sir. Apparatus dew point temperature.
Apparatus dew
apparatus,
point.
correct, apparatus dew
Apparatus
point temperature. So you can see that this S is a little away, okay, because of your bypass factor that comes into the picture. What is bypass factor? Can anyone explain?
The inability of the
The number
depression
of
not achieved divided by total depression achieved.
Okay, so if your bypass factor was 0, okay, if your bypass factor was 0, then all of the air is going to come in contact with your all of the air is going to
cooling or
come in
heating coil.
contact with the coil. So over here, your ADP might be slightly higher. Okay, it may be slightly towards this side, because bypass factor is coming into the picture. Therefore, you need to have a slightly lower ADP so that you can get your net desired cooling effect, because some amount of air always bypasses the coil. So your ADP is going to be slightly lower, or it may not coincide with your supply air condition. Okay, so this is how you draw your RSHF line. Okay, but now you would say that RSHF का तो यहाँ पे scale होता है, right? RSHF का scale यहाँ पे होता है. Okay, so uh, if you have opened your psychrometric charts, there will be, you could locate a one uh,
Hello.
a specially
Hello.
marked point over here.
Hello.
So, hello, am I audible?
Yes, sir.
Yes, sir.
Yeah. So if you
Yes,
open
sir.
your
Yes.
psychrometric charts, you could locate one point nearby here, like this. It will be marked like this.
Yes, sir.
Okay, it
25
is,
degrees DBT.
yeah, 25 degrees DBT, and I think it will be 50% relative humidity. So this
Yes, sir.
this point this point is your alignment circle. Okay, we call it as alignment circle. Okay, so how do you plot a 0.9 ka RSHF line? Okay, first you will have to select the scale on the, that is on the right hand side. You'll have to select the scale that is given. Okay, on the right hand side over here, you will find 0.9 marking over here. So from that marking, you'll have to draw a straight line passing through the alignment circle. Okay, is everyone understanding?
Yes, sir.
Yes.
Yes,
So
sir. Yes, sir.
yeah, so this line that you draw from point 7, or sorry, point 9 RSHF, passing through the alignment circle, this is your RSHF line. So this line you will have to draw a parallel line but passing through the room design condition. Okay, understanding?
So was 0.7 taken as an example?
No, we are taking point 0.9
0.9.
RSHF as example. Okay,
Okay,
from
point
this,
nine. Oh,
yeah, from the scale of RSHF scale that is there on the right hand side, you will locate point 0.9, and from there you will draw a line passing through the alignment circle. Okay, so that
Yes.
same line is going to represent cooling and dehumidification with RSHF, or room sensible heat factor, of 0.9. So that line you have to draw parallel so that it passes through your room design condition point. Okay, understanding?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So this is how you draw your RSHF line. Okay, so after you understood this, we can proceed further. Yeah, just what I was discussing. You have your RSHF, your sensibility factor scale over here, and you will draw that calculated RSHF factor and a line passing through the alignment circle. That same parallel line you will make passing through room design condition, room condition. So this becomes your RSHF line. Okay. Next is your GSHF line. What does GSHF mean? It is your grand sensible heat factor, and it includes the outside load. Okay, so outside load means whatever the recirculation air that comes inside, or it is allowed to come inside, it mixes with your indoor air with with some percentage. Okay, that generally that percentage is, it varies between 20% to 60-50%. Okay, so your outside air is going to get mixed with your room air. Okay, so over here we can see this point 3 is your mixture condition. Okay, that means that some amount of air from this outdoor condition is going to get mixed with this room air. Okay, is going to get mixed with this room air, and the resultant property, okay, will lie in between these two properties, and it depends on the fraction of whichever the air is greater. Okay, if your room air is greater, which generally is the case, then this point number 3 is going to be closer to the room air condition. Okay, so uh,
Yes.
then the mixture condition point that you have got, point number 3, from there you can draw a line which is going to meet this RSHF line on the 100% relative humidity line. I'm repeating again. This point 3 that you have got after the mixing has taken place, from there one more line you can make which is going to meet the RSHF line at the 100% relative humidity. So this line forms your GSHF line. Okay.
Sir, how will
So
we get point number 3?
okay, I'll repeat again. See, you have your outdoor condition or your outdoor air. Okay, let us say the outdoor air is at 38 degrees. Okay, let us say the outdoor air is at 38 degrees.
Yes, sir.
Just write it down over here. Okay, 38 degrees. Okay. Let us say our room air is at 24 degrees.
Okay.
Okay. So now whenever mixing happens, okay, whenever mixing between these two conditions happen, the resultant air is going to have properties in between these two. Okay, that is
Yes.
acceptable to all. So
Yes, sir.
depending on the fraction of whichever air is greater, okay,
Okay.
depending on the fraction of whichever air is greater, this mixture condition is going to be closer to that point. For example, if
Okay.
75% room air is mixed with 25% outdoor air, then this
It will
point
be
3 will
towards
be
room air.
closer to this room air. Okay, so if it is in the ratio of 4:1, then you will split this line into 5 parts. 4:1 means 4 parts of air are mixed with 1 part of outdoor air.
Outdoor.
So you'll split this line into 5 parts. Okay, and you will after the first part, your mixture condition will be occurring. Okay, after the first part
Yes, sir.
from your room air, your mixture condition will be occurring. So you will get the
Okay, sir.
properties of mixture condition. Okay, so
Yes,
now
sir.
when you draw a line starting from mixture condition to the to your coil temperature, okay, to your coil temperature, that is on your
Yes, sir.
100% relative humidity line. This line now is your grand sensible heat factor line. Okay,
Yes, sir.
so this is valid if, I mean, this chart is valid if your bypass factor is 0. Okay. So please, I want you all to note down this chart. Please note down this chart.
Sir, wait.
Yeah, I'm waiting.
Sir, sir,
Yeah, tell me.
GSHF RSHF सैचुरेशन वाले लाइन पे मिलेगा या कहीं पे भी मिल सकता है?
This is only valid, this chart is only valid if your bypass factor is 0. That means that your coil temperature and your ADP is the same. Coil temperature, ADP and your supply air condition. Okay, ये supply air
Okay,
कब
sir.
होगा same as coil temperature जब bypass factor 0.
Got it. Thank you.
So we'll come to the next condition as well where the bypass factor is greater than 0. Everyone has noted down this diagram?
Just a second.
Yes.
Done, sir. Done, sir.
Wait. Sir, done.
Done? Okay. So next condition is where your bypass factor is greater than 0. Okay, so that means that your temperature of air that leaves the cooling coil is greater than the temperature of cooling coil. Okay, so here you can see that uh, when you locate this mixture condition, okay, then your GSHF line will be not touching this RSHF line at this point. Okay, because of some bypass factor, you need
NIME माइक बंद करना तेरा.
a lower ADP. Okay, is everyone understanding this? Because of your bypass factor, the temperature of air that is leaving the cooling coil is higher than the cooling coil. So your ADP required has to be lower. Okay, it is going to be at this point. Okay, so how do we locate this point is a different story altogether. Okay, the supplier condition you will understand when we start solving numericals how to locate this point. But at the moment you need to understand that because bypass factor is greater than 0, this ADP is not going to work. We'll need a lower ADP. Okay, so your GSHF line originating from the mixture condition has to be slightly lower, and the intersection of RSHF line and GSHF line would give us the supply air condition to the room. Okay, ये इस टाइम पे थोड़ा confusing लगेगा, but when we start solving numericals it will be fairly easier. Only thing you need to understand here is that whenever you are starting to solve numericals, first you will locate the outdoor condition over here. I'll just explain the steps. You locate the outdoor condition over here. You locate the room design conditions over here. Okay. You will then find RSHF value. Okay. And going by the SHF line on the right hand side, you will form a line for RSHF from the alignment circle, and then you will make that same line parallel but passing through the room design condition. Okay, and then after you locate the mixing point, and if the bypass factor is given, then you can easily draw this line. Otherwise there's a different method. We will explain that later on. Okay, is everyone understanding this?
Yes, sir.
Okay.
थोड़ा बहुत समझ रहा हूँ उतना ज़्यादा
हाँ, ये part थोड़ा difficult जाएगा because unless you practice with your own hands, you won't understand that easily. But you just need to understand what is RSHF line, what is GSHF line. Okay, RSHF line is going to cater to the room loads. Okay, the loads that are present in the room only, and GSHF line is going to cater to the room loads plus the outside air which mixes. Okay, outside air which mixes with the room air. So naturally GSHF line is going to be having a greater slope as compared to the RSHF line.
Yes. So in the first condition where the bypass factor was 0, for drawing the GSHF line, we directly connected point 3 to the point where RSHF line reached the that point,
Correct,
point
correct,
4.
correct.
So in the second case, how do we draw that GSHF line?
Yeah, that is what I'm telling. I will apply a different methodology that I'll explain you when we solve that type of numerical.
Okay.
Okay, basically it involves a trial and error method wherein there's going to be one set of value for this point and one set of value for this point, which is going to satisfy the bypass factor ka formula. Okay. And there's one more line that we can draw, which is your effective sensible heat factor. This is not really of importance, but I'll just explain the importance of this. This line basically connects the room condition. This line basically connects the room condition and your apparatus dew point temperature. That's it. There's no other significance of this line. Okay.
Yes, sir.
So
Yes,
now
sir. Yes.
we can start with a basic numerical. Okay, I want you all to just note down the question quickly because we are running short of time. This is a fairly simple numerical. I mean, it's just from your for your understanding point of view that I have kept this numerical over here.
Done, sir.
Okay, so here it is in this question it is given that the room condition is 24 degrees and humidity is 60%. The room has a sensible heat load of 132 kilowatts and 83 kilogram per hour of moisture is to be removed. So sensible heat load is given as 132 kilowatts. We have to estimate the latent heat load because they have just given the mass flow rate of moisture, mass of moisture that is being added per hour. Air supplied to the auditorium is at 15 degrees Celsius. This means that the supply condition of air or the air that is leaving the cooling coil is 15 degrees Celsius. I have to find how many kg of hour air per hour must be supplied to the room. What is the dew point temperature of supply air and what is the relative humidity. So here we will first start by finding the room latent heat. Okay, here it is written cooling load, but it essentially means heat. Room latent heat is 84 kg uh, divided by 3600. That is going to give you 84 kg per second into the latent heat at that temperature. Okay, so HFG, the value of latent heat at 24 degrees Celsius, you will find out that it is 2444.9 kilojoule per kg. So from that we will find the room latent heat, and after that we can find the RSHF by your this formula, that is room sensible heat upon room sensible heat plus room latent heat. It comes out to be around 0.6982. So you'll go to the scale that is there on the right hand side. I want you all to open your psychrometric charts. There is sensible heat factor scale on the right hand side, and you'll
Sir, the HFG is obtained from the other book, right?
Steam table.
yeah
Steam
steam
table.
table में रहेगा
Table.
ये value. Okay, you'll have to find this from your steam tables. So after evaluating RSHF as 0.6982, you will try to locate this point on your psychrometric chart, and you'll try to draw this line from the alignment circle. Okay.
Yes, sir.
सबको ये लाइन बना के हो गया सबका ये लाइन?
सर एक सेकंड.
No, sir. Yeah.
No, sir.
Yes sir, done.
So now you locate the room condition on the psychrometric chart. You locate the room condition, 24 degrees Celsius, 60% relative humidity. And then you will draw a line parallel to the RSHF line passing through your room condition.
So can you repeat how to plot it?
हाँ yes sir, can you repeat?
Okay. RSHF का वैल्यू तुमने लोकेट किया,
हाँ.
अलाइनमेंट सर्कल लोकेट किया, उन दोनों को लाइन ज्वाइन कर दो उन दोनों को.
कर दिया सर.
फिर रूम डिजाइन कंडीशन लोकेट किया. So using a roller scale, you will just simply draw a parallel line passing through this room design condition and meeting at the 100% relative humidity line or on the left hand side. आ गया सबको?
Yes sir.
So next is so our total cooling load or the total heat inside the room is your room sensible heat plus room latent heat. So you just have to summarize summation of those two numbers is going to give you your total room heat. Okay. So that heat has to be catered by the mass flow rate into the enthalpy difference of the supply air minus the room air. Okay. So for that you will have to locate those 2 points. Now room condition you have already located, right? Room condition you have already located over here. You also need to locate the supply condition. So it is given in the question that the supply air is at 15 degrees Celsius, right? Arrival temperature 15 degrees Celsius. You'll just simply draw a vertical line till your line that you have just made from passing through the room design condition, and that point is your supply air condition. So you will find the enthalpies at S and R as shown in this diagram.
Sir, 42.5 and 53.
Okay, so here in this, okay, here it is given 39 and 52.7. So that's okay, that's acceptable.
Yes sir, 39.
So 39 आ रहा है ना, ठीक है.
हाँ.
So your room total heat, the room total heat, that means the heat inside the room, वो heat कौन absorb करेगा? The cold air that is coming, right? So cold air is coming from the cooling coil at your HS enthalpy, okay, or from point S, and it is absorbing the heat till your room design condition, that is HR. So room total heat is equal to mass flow rate of air into HR minus HS. Okay, that is the enthalpy of air inside the room minus enthalpy of air that is entering the room from the conditioner coil. So from this you should be able to get mass of air supplied in the room as 14.5 kg per second. ये आ रहा है सबको?
Yes, sir.
Yes. So next is we have to find the dew point temperature. So the point at which your line was meeting the 100% relative humidity line. This
13
point
degrees
that is,
Celsius.
yes.
Less than 1 minute. 13.
Yes,
13
this.
degrees Celsius.
So it should be around 13 degrees Celsius. So that's right.
13.
Yes.